Welcome, Chris.
Hi, guys. Hey, happy to be here. Let's get this party started. But let's be real here. So when you're first learning how to build a smart contract, it's a challenge. You don't just learn a new language. It's about you have to understand the decentralized application architecture. You have to understand blockchain concepts like what deploying a smart contract means, or how to interact with that smart contract, and how that smart contract is executed by the underlying blockchain. Now, these added complexities often scare away new developers. So smart contract development has to be dead easy. Now, the Algorand engineering team has done an amazing job in creating these two languages. PyTeal, our official smart contract language. Give it up to the engineering team over there. They're the ones working on this PyTeal right now. And the Algorand with your smart contract. Now, these are powerful languages that let you create complex and full-scale smart contract on the Algorand blockchain. But if you're someone new, just starting your blockchain journey, these can feel a bit unfamiliar, complex, and overwhelming to just get started. So we kept asking the question, how can we make smart contract development easier? We want to attract Web 2 developers who have never built on a blockchain before. And the answer to that question is the Beaker framework. Hello, everyone. My name is Chris Kim. I'm a developer advocate for Algorand, and my job is to make developing on Algorand simple, easy, and fun for you guys. By the end of this presentation, you'll have a full understanding of what the Beaker framework is and why the Beaker framework is going to completely upgrade your developer experience on the Algorand blockchain. All right, let's get started. So before we dive into Beaker, I want to quickly cover what the dApp architecture looks like on Algorand. So what you see on screen right now is a familiar Web 2 app architecture. We have the front end and the front where the users interact with your application. We have the web server that hosts the server, handles API calls, and the database that stores relevant data for your application. Now, an Algorand dApp architecture isn't too different. It still has those three components, and all you add on to that is the Algorand blockchain. And on the Algorand blockchain, you deploy a program called a smart contract, which is a program that lives on the blockchain that executes transactions under certain conditions. And that smart contract is executed by the Algorand virtual machine. Now, to deploy and interact with the smart contract, you use the Algorand SDK, either directly from the front end or through the web server. Now, today, I'm going to focus on these two things right here, the smart contract and the Algorand SDK, because that's what the Beaker framework improves. So introducing Beaker, the way dApp development should be. Beaker is a Python smart contract framework. When you're writing smart contracts using PyTeal, it improves the code organization and makes it more familiar for Python developers out there. When you're deploying and calling smart contract using the Algorand SDK, it makes it more easy to set up the front-end code and lets you get directly to deploying and interacting with your smart contract. It also provides tooling for debugging. So overall, it's a framework that abstracts away the complexity that you don't really have to think about and lets you focus on building your product. So I want to show you guys a quick code and a direct comparison of a simple calculator application written in bare PyTeal and Beaker. So I'm going to go over to my VS Code, and let's first take a look at the calculator smart contract written with PyTeal. All right, so we see I'm sure this router class is now familiar because of the previous presentation. We have the router class set up here. It defines how the routing happens when the smart contract should execute certain part of the smart contract. And if you take a look at inside of the bare call actions, we see that if it's an application create transaction, you approve it. If it's an update or delete transaction, you check if the transaction sender is the creator of the application. If that's true, it approves. If not, it fails. So it defines all these rules for you. Now, this router class would be something a new developer would be unfamiliar with. And then down here, we have the four functionalities of the calculator app to add, to subtract, and to multiply and divide. And all of these methods are decorated with the router.method decorator that's connecting these methods to the router class that we defined above here to let the front end know, hey, if you want to call the add method, the router class connects that and route it for you. Great, so down here, when we run this Python file, I'm going to dump out 3 files, the contract.json file, the approval, and the clear program. So these are the 3 files that is spit out when you run this file. Just to quickly show you what it looks like, this is the approval teal program auto-generated by your PyTeal contract, the clear program, and the ABI JSON file. It looks like this. All right, now let's deploy the smart contract and interact with it. So I first want you to take a look at line 11 right here, where we're importing this function called getAccounts from Sandbox. So I have a separate file here that I've manually written, and I built this helper function to retrieve accounts that are given by Sandbox for you to play around with. So this is all code that I have manually written. Going back to interact.py, I'm going to define a couple helper functions. I have a create app function here. It takes in a bunch of parameters, and all it's doing is it's going to send in create an application create transaction. It's going to sign it, it's going to send it, and it's going to wait for confirmation and return the result. Another helper function here, compile program. It's going to take in the source code, compile it down so that you can use it when you're creating your application. More setting up to do. We're going to set up the Algorand client so that you can interact with the blockchain. We're going to use the getAccounts function that I defined in the different file and to get an account. We're going to read in the approval program and the clear program from the file system, and then we're going to use the compile program helper function to get an approval program and clear program. Here we're going to define some state storages. When you're deploying Algorand smart contract, you have to define how much local storage and global storage you want to have, and we're going to use that to define the global and local schemas. And finally, we're going to take all of that, put it into this create app function, and deploy your calculator application. Now, we're going to read in that contract.json ABI file here, and then we're going to use that to finally interact with your calculator app and call these 4 functions. So that's what interacting, deploying, writing smart contract looks like with PyTeal and the Algorand SDK. So if I go to the terminal here, and I run this file, python interact.py, you can see that the app was correctly deployed and the 4 functions were properly called. Now let's take a look at what that looks like with Beaker. So this is the folder right here. I opened that up. It's 1 file. That's a good sign, right? So let's take a look at it. So in line 9, you see a class. This looks like a Python class, right? When I expand that, you can see the 4 functions that you saw before, but this is the complete smart contract written with Beaker. No router class, no need to connect it to the router. It's all done in the back, and it just looks like a normal Python class. Now to interact with that, we're going to use the sandbox module provided by the Beaker framework to set up the Algorand client to get accounts with 1 line of code, helper functions, and then we're going to create this thing called an application client. And we're going to take the 2 values that we got from up here to create a client for an account. And this client will be used to deploy and interact with this smart contract. And if you look at line 40 here, app client.create, that's it. That's how you deploy a smart contract with Beaker. And then you right away get into interacting with the smart contract, and you just do app client.call, and you can call specific external methods that are defined in your Beaker contract. Let's go back to the terminal. Now I'm in the Beaker folder. If I run this file, you can see that it has the same result. All right, let's do a quick recap. So what did we just see? The calculator app written with bare PyTeal. The smart contract code seemed a bit unfamiliar. We see this thing called router class. That's something that you have to learn. We have to manually define helper functions to deploy our app and to compile our source code. And so the front-end setup was very lengthy. Now with Beaker, the smart contract organization was very familiar. It's like a Python class. The helper methods were defined for you just to use right out of the box. So it was much easier to deploy and call your smart contract. All right, let's talk about setting up your development environment if you want to build with Beaker. So these are the 4 packages that you want to install. You want to have Sandbox to have a local private blockchain running in your computer so they can test against when you're building your smart contract. And you want to have PyTeal, Python SDK, and Beaker installed to build your smart contract. Take the time to scan this QR code right now. I just created a Beaker starter kit. So this will take you to a GitHub repo, and it's going to have 2 folders. One, a completed code folder, where it has all the code that you will see in this presentation. And the starter kit folder will have the same files, but it will be missing some code. So you will have to, this is the homework, you will have to go there and fill in those blanks and make those files run, because I believe learning by coding is the best way to learn. I have the instructions of setting up the projects folder and installing all the required packages down there. But for time constraints, please do come back to this slide afterwards and try it out yourself. So these are the Beaker components. We have 3 pillars. To improve smart contract development, we have these 3 components down here. We have the application client for deploying and calling, and we have Sandbox module for testing. Now let's talk about how Beaker improves smart contract development. So that's the right pillar over here. Let's first talk about the application class. So what you see on screen right now is a simple smart contract with Beaker. It has one external method called hello, which returns hello with whatever argument that you pass in. But I want you to focus on this highlighted code right here, the application class. Okay, so we're inheriting this application class, but what is it? It's a base class that all Beaker contracts inherit from, and it provides basic functionalities that all Beaker contracts use. So it includes logic like detecting state variables, on-complete methods, ABI methods, and internal subroutines. So it's abstracting away all of these things, the routing and all that, and you can just, that means your code will be much simpler. Let's talk about states. So on the Algorand smart contract, there are 2 states, local state and global state, and now we're having box storage being added. It's coming soon to mainnet in a couple of days. But on Beaker, the global state, we refer to it as application state. They're the same thing, but I'm going to refer to it as the application state. Now, before we start talking about it, I want you to take a look at this code right here, where we're using the final typing construct. So why are we doing that? So this is not mandatory, it's just good practice. So that's preventing reassigning of the variable, so it just reduces the chance of introducing a bug into your smart contract. So we highly recommend you guys do this, but it's not mandatory. All right, let's talk about application state. So this is how you set up an application state inside of a Beaker contract. You use the application state value up there. It has 5 characteristics that you can set up. If you take a look at the code, we see that the stack type is set equal to teal type .byte. That means this state has a byte value. Default set equals to, this value is immutable in byte. So a default means that when the smart contract is deployed and initialized, this is the value that it's going to have. Static is set equal to true. That means that this state is immutable. You cannot reassign new values to this state. And then we have a description explaining what this state is about. Now, what's amazing about Beaker is that it exposes this state to the ABI. So this is what it looks like in the ABI. You can see that the type of the state, the keys, and the description is exposed in the ABI, so the front end knows how to interact and use this state. It will be much easier for them. The second type of application state is a dynamic application state. A dynamic application state is like a dictionary type state where it has multiple key value pairs stored in it. This will have 4 characteristics that you can define: stack type, max keys, keygen, and description. Here, I just want to mention out what max keys is. That's saying that the code here is set equal to 32. That means this dynamic app state can only have 32 key value pairs. Same story here. This is exposed to the ABI. All the informations and characteristics are exposed, and it will just be easier for the front end to know how to interact with this state. Now moving on to local state, or in Beaker, account state. Same story here. You set up the account state the same way you would set up an application state. It has the same 5 characteristics, and all that's changing is instead of application state value, you're doing account state value. And same goes for dynamic account state. It has the same 4 characteristics, and you set it up the same way. And account state is also exposed to the API. All right, moving on to decorators. Beaker provides 3 decorators for you to use: the external decorator, internal, and on-complete externals. Now we're going to take a deep dive into what each of these decorators are doing for you, but all of these decorators support authorization. So what that means is when you decorate methods with these decorators, you can say, hey, only this account, certain account, can access this method. So let's take a look at what that looks like. First, starting off with external decorator. I took a code snippet from the calculator app here, the add method, and you can see that is decorated by the external decorator. So what is that doing? What that's doing is exposing this add method to the API. So when you take a look at the API, you will see the add method written there, and it will explain what type of argument it takes in and what kind of output it outputs. It's also adding the method to the router. So this is how the smart contract knows when to call this add method. So the external decorator is doing all that for you in the back. It's like magic. All right, moving on to internal decorators. We have 2 methods up here. Let's first take a look at the internal add method decorated by the internal decorator. So what is that doing? Inside of the parentheses, it says teal-type.un64. That's just saying that this internal method is going to return a UN64 type. And what's cool about internal decorator, internal methods is that they're not exposed to the API. So when you look at the API, this internal add method won't be there. So internal methods are used internally, like the name suggests, and the other external methods inside of the smart contract can use the internal method for computation or other stuff. So how do you access it? This is an external method called add with internal. So it's doing the same thing as add, where we're using the internal method to do the same thing. If you look at the highlighted part, in the Python class, you access it with self. So internal decorators are great when you want to have repeated complex computation defined to use in multiple places. Our last decorator, the on-complete externals. So on the Algorand blockchain, when you're interacting with your smart contract, there are special types of application transactions. These are the 6 application transactions that the Algorand blockchain supports. But on the slide, I only have create and delete up there. So what this means is if the front end says, if someone says, hey, I want to send in an application create transaction, that's going to call that create method right there. If someone sends a delete transaction, that's going to call the delete method down there. Finally, let's talk about authorization. So here, we're saying that this delete method will only be authorized to be called by the creator of the application, which makes sense, right? We don't want everyone deleting your smart contract whenever they feel like it, right? There are 2 other things that you can authorize. You can authorize accounts that hold certain tokens or authorize accounts that have opted in to the smart contract. If these don't fit your need, you can create a custom authorization logic by yourself as well. All right, let's move on to how Beaker makes deploying and calling smart contract easier. So I'm going to talk about these 2 components for now. And let's start with the sandbox module. Now, don't get confused. The sandbox module here provided by the Beaker framework is not the same thing as the sandbox that lets you run a private local blockchain on your computer. This sandbox module provides some helper functions to get values and interact with the sandbox that you have running in the background. So the code here, the highlighted part, is we're doing sandbox.getAccounts. That's going to get a list of accounts provided by Sandbox. And if I print that out, you'll see 3 Sandbox account objects, each object including an address, private key, signer, which are all the things that you need when you're testing, when you're building your application. Here, I'm just popping one off from that list, and I'm going to print out each of the attributes, and that's how you would gain access to these values to use in your testing. And finally, you can use Sandbox to set up your LD client with one line of code, and just to showcase what you can do with those clients, you can get the minimum fee of the Algorand blockchain, just like that. All right, moving on to my favorite part of Beaker, the application client. So up here, we're doing the same thing. We're using the Sandbox module to get the accounts to set up the Algorand client. And we're going to use those two values to set up the application client. The application client takes in 3 arguments: the Algorand client, an instance of your smart contract, because it's like a Python class, you can create an instance of it, and then a third argument, which is a signer of your account that you want to create the application client for. So what is an application client? It's a convenient way for you to deploy and interact a smart contract for an account. Now, if you take a look at the definition of this application client, these are the helper functions that are defined in there. That's about 20 helper functions just ready for you to just use right out of the box. This means if you're not using Beaker, all of these functions you would have to manually written, and that's saving you about 750 lines of code. So Beaker is a powerful, powerful framework. The code right here is a demo code of using the application client that we just created. So I'm just going to highlight the part of the code that is actually using the app client. So starting from the top, we see that we're using the app client to create the application, to fund it, to opt in, call external methods inside of the smart contract, to get application account info, to close out, and to delete the smart contract. And notice how all of these you can do with one line of code. No more manually creating transactions, signing them, submitting them, and waiting for confirmation. The application client handles it for you. So that's it, guys. That's everything about Beaker. So what did we learn today? Let's do a quick recap. We first talked about what a dApp architecture looks like on Algorand, just to do a quick comparison of a Web 2 application and a Web 3 application. And it's not too complex. We're just adding the Algorand blockchain, and a smart contract lives there, and we interact with it using the Algorand SDK. And then we talked about how to set up your development environment to build with Beaker. And then we took a deep dive into what Beaker is, looked at each of the components, and why it's such a powerful tool. Well, that's it, guys. Please take time to scan these 2 QR codes here. The QR code on the right, is that left or right? Right, yes. Right here is going to have all the resources that you will need to become an Algorand developer. The link to this slide will also be in there, so please scan that. The QR code on the left is going to have my social media information. I'm not sharing this to increase my Twitter followers. I want to reach 1,000 though. But jokes aside, the reason why I'm sharing it is because I want to connect with you guys. I want to help you guys answer your questions and connect you guys to the right people when you're building your application. So hopefully, I hope that my presentation has given you a fine understanding of what the Beaker framework is, and I hope it inspired you to look deeper into this framework and start building on the Algorand blockchain. Thank you so much.
Stuff, Chris. Thank you very much. You got some time for questions. Let's look out here. Does anybody have some questions for Chris on the Beaker framework? Put your hand in the sky, and we will come and
we got one
to you.
Back there.
All right, speak loudly because it's hard to hear up here.
All right, let's see if I can answer these questions.
A rather dumb question here. What are the situations when we do not want to use Beaker, or can we use it for every eventuality?
I'm so sorry, I can't really hear you. Can you say that again, please?
What are the situations?
I see. So the question was, when should we not use Beaker, or should we always use Beaker? Well, Beaker is a framework, so it's another layer of abstraction, right? So if you're the type of developer who wants to be certain what's happening with your code, you might prefer to just build with bare PyTeal to give you more control over what you're building. Beaker definitely makes it much simpler, but it's relatively new. We're still doing some testing on it, so it could have some potential bugs that we are not aware of yet. But But those are like the pros and cons that I guess you will have to wage when you're deciding what you want to use. Yep, back there, and in front here.
I have a question about a developer community. So when we debug code, if we find some problem, like is this algo devs resources is the place we can send our questions?
Yes, so the Algorand resources, it will have multiple links like to the Discord, to the forums. I would say Discord is the best place to get your questions answered. We have Ben, Steve, and our DevRel team always on there answering questions. I would say the forum is also a great place to get your questions answered. But yeah, you should have all the links to the resources there.
Yeah, and related to that, is there like a physical in-person gathering together around the city?
So the question was, is there like an in-person help session?
Yeah, because a lot of time the coding exchange by online is not as effective as you just sitting down with your neighbor and debugging the code together.
That's right. I don't know if you can. Well, we do hold workshops, in-person workshops, and I think those are the places where we can answer questions in person. I would say right now is a great place to get your questions answered. But we do hold virtual office hours to help you help answer those questions. Yeah.
Hello, thanks for the great session. Just wanted to quickly clarify one thing, and I'm sure you covered this already, but for cases when the contract is already deployed and you have an app ID, if I got it correctly, does this mean that you simply need to pass that app ID to the application client when you initialize it? Or essentially, is like what way to deal with instantiating the application client class when you already have the contract deployed? Because a lot of demo examples in the Beaker repo is I suppose for the demo purposes, every time you compile it, you deploy a new contract, right? But what's the best practice to instantiate it if you already have it deployed?
Okay, I got app ID. I'm so sorry. This reverb is crazy. Did you get that question?
Yeah. I mean, it has to do with when you instantiate the app client. Typically we are just redoing it, right? And so you do have the ability to specify a particular application ID. If you don't specify that, then it is going to create it by default. So if you're using the Beaker framework and you have the extension within VS Code installed, the syntax highlighting will pop up and it will tell you about that in there. Yes. So to follow on then, yes, you can have your testing harness that is using a pre-deployed smart contract, and then you are always specifying your identifier so that you are always calling that contract. Do we have one more? We have time for one more question before our next speaker?
Yeah,
right here.
sorry.
Great.
So just one quick question. How do you decide what makes its way to Beaker and whether it goes all the way back to PyTeal? So certain functions are essentially shorthands for PyTeal code that you would write very frequently, right? So rather than doing that regularly, if you use Beaker, you can just do that in one line of code, as you alluded to earlier. So how do you decide whether that feature goes into Beaker or makes its way back to PyTeal as a standard PyTeal feature?
I got part of that question. Is the question asking Beaker is shortening these PyTeal?
Yeah, because Beaker, so part of the Beaker code compiles down to PyTeal, right? Or is?
Yeah.
I can answer that question. So how do we make the decision of, we put in a bunch of stuff that makes the smart contract writing easy and takes out a bunch of the code. Why is that in Beaker and not in PyTeal? That's basically the question. Yeah, so for right now, it all lives in Beaker. It's more of a, I'd say, a playground, right? Things are going very rapidly there. We add lots of new features very quickly. I think over time, that decision and that's, I don't know why I'm holding these right now. that decision becomes like a much more front and center question of like, hey, what's the strategy here to move things between them? Is there some concept of like a standard lib in PyTeal? But for now, this is all about just like finding the problems, mowing them down, and providing a framework that just makes things very, very, very fast and very easy on PyTeal. Cool.
Great, and you're hearing that directly from Paul Regal, our Chief Product Officer, so thank you for jumping in. We got Ben Gudarelli right here as well, the lead developer, so, you know, turn and face the camera so that everybody knows you. Yay, all right, awesome. All right, Chris Kim, thank you very much for this very informational introduction to what Beaker is. Awesome.